In this tutorial, we are going to look at clocking the event table using Reactor's MIDI clock. Right-click, select Built-in Module, select MIDI In, and select Song Position. When we start Reactor's clock, the output from this module counts upwards until stop is pushed. 96 events leave this module per bar. These numbers are called ticks. When we hit stop again, the clock will reset to 0. We need to quantize the event table in a meaningful way with respect to the tempo of the song. We may want the event table to send out data on each beat of the bar, or perhaps every eighth of a bar, or another value. In other words, we need to be able to adjust the rate at which these ticks are sent. Right-click, select Built-in Module, select Math, and select Modulo. This module divides the input at A by the input at B. The answer expressed as a whole number is released from the top, whilst the remainder is released from the bottom. We will use this to divide song position by our tempo value. Right-click, select Built-in Module, select Panel, and select List. We are going to label our list Tempo. We are going to change the style of our list to Menu. We are going to have 4 positions to switch between. Select Function and in the number field, type 4. We now have 4 entries for our list. Let's label each of these positions. The first is going to be labelled 1/1, representing a whole bar. The second is going to be labelled 1/2, representing half a bar. The third is going to be labelled 1/4. And finally, the fourth entry is going to be labelled 1/8. In the Structure panel, right-click, select Built-in Module, select Signal Path, select Selector Scanner. This module will be used to complete the switching process. We need the same number of ports to match the number of switch positions. In the field for minimum number port groups, type 4. In the Structure panel, create a constant for each of the inputs on the switch by right-clicking on the ports. Select Create Constant. The first input is used to trigger an event every bar. We need to add a value of 96 here, as there are 96 ticks in a bar. The second input is used to trigger an event every half a bar, so we need a value of 48. Basically, we divided 96 by the beat length. When we make a selection on the tempo list, for example if we select 1/1, the list will tell the selector to release the value at the port labelled 0. 96 is therefore released from the selector's output. If, for example, we selected a quarter of a bar in the list, a value of 2 is sent to the selector module, and 24 is released from its output. Let's wire our selector into the Modulo module so that the ticks are divided by these values. Next, right-click, select Built-in Module, select Event Processing, and select Step Filter. By inserting a step filter, events are only passed through when there is a numerical change in its input. Next, we need to tell the event table when to loop back to the beginning. Right-click and select Built-in Module. Select Math and select Modulo. Wire the output of the step filter to the A input. Right-click, select Built-in Module, select Panel, and select Knob. The knob is going to control the amount of steps that we have in the display. It will allow us to lengthen or shorten our loop. Using the range fields, let's make maximum value 32, with 32 steps. Unlock the panel view and arrange the knobs. Label the knob Steps. The XR input controls the amount of X rows in the event table, so let's wire our knob into the XR input of the event table. By connecting the Steps knob to XR, we can control the length of the loop. We need to divide the event length by the number of steps in a loop cycle. To do this, we need to wire our Steps knob into the second Modulo module. The output from the Modulo needs to trigger the read position. Wire the mod output into the RX and R input ports of the event table. There are a few things we need to check before our macros will work. In the View section, make sure the X alignment scroll bar is positioned over to the left. Make sure X AutoFit is not selected. Make sure the X value in table size matches the maximum number of steps. We want 32 steps. Make sure all the modules are monophonic. Right-click on each module and select Mono. Finally, test the event table has been successfully clocked by starting Reactor's MIDI clock. Draw in the table and try different tempos using the tempo list. Test that you are able to change the amount of steps in a loop.